Okay. Hey. All right, it's working. What's up? Oh, I have no idea how to pronounce that, but ayo. All right. It's my first time streaming on YouTube. I used to stream on Twitch during COVID, so I'm just getting used to the controls. Actually, I think I have it. It's pretty straightforward, to be honest. What's up, Justin? Hey, Jackie. I'll figure out a good countdown timer for lecture starting. I don't know if I like this, but... Learn with Salim. What am I doing here? Hey, maybe you want to learn some CS2 again. Oh, Jack, I think this will be the best setup, at least for the summer, streaming on YouTube. Then the videos are just automatically on YouTube. Yeah, this is a summer session. So we got a 6-week CSE116 coming up. It's going to be intense. It's going to go fast. And it starts in 1 minute. I don't know how everyone's going to handle this in 6 weeks. But we'll see. It's a tough course when it's a 15-week course. That said, I trimmed some of the fat to make it fit into 6 weeks. I mean, Jackie can still edit them. Like, you can trim out, like, pre- and post-lecture stuff. If I ever have to go to the bathroom, you can cut that out. If you want to edit videos, go for it. But this way I don't have to. Like, no one has to. Because I only have one TA. They only, it's limited funds in the summer to hire TAs. So, there's not a whole ton I can do. Yeah, we're about to speedrun CSE116 starting right now. Alright. Welcome to the summer CSE116. This will be a strictly online course. But anyone registered, you already know that. It will be public, so anybody else, you're all welcome to hang out and chat and keep us company. But other than that, let's just get into it. There's quite a bit of delay on the broadcast, isn't there? It's fine. All right, so let's go over the syllabus and what we're going to be doing this semester. Is going to be a speed run of CSE116. It's going to go very, very fast. We're doing this in 6 weeks. Just to give you a heads up, this is a very difficult course as it is. Their students tend to struggle with it. So doing this in a 6-week course, make sure you're on top of things. Staying on top of everything will be the most important thing. Making sure you're watching the videos. All of you who are registered, I did say in my email last night that you don't have to watch the lectures live, but I strongly, strongly recommend watching them the day that they're broadcast, at the very least, if you're not going to watch them live. Make sure you're staying up, especially when we have Tuesday and Thursday lectures. If you're waiting till Thursday to watch Tuesday's lectures, you're already so far behind that you're not going to sugarcoat it. You're probably going to fail at that point if you fall a whole lecture behind. it's going to get tough. So let's go into what we're going to learn. Something I always used to say in CSE115, and those of you from other schools, I know some of you are taking this from outside of UB, whatever your first computer science course was, whenever I teach that course, I like to say you learned everything that you need to do anything that you want. Any coding that you want to do, you can do it with everything you learned in your first CSE course. We learned all the basics, variables, functions, control flow. We used to, we're not going to anymore, but we even used to teach some basic networking and web development at UB. And you could do literally anything you can imagine with what you learn in that course. It's what we call a Turing complete language. You learn everything that is needed to code absolutely anything. Now, it might take you a while to code programs that are larger and more complex, but you have all the fundamental knowledge to do whatever you want. So what's left to learn? In one semester, we taught you everything. What's left? Well, the focus in CSE116 is how do we write large programs? And this is going to come in a few different flavors. Mainly, how do we test our code? Well, in your first CS course, you hobble some code together. You usually submit it to an automated grading tool, and you hope that the grading tool just says, yep, you're good, this code is okay, and maybe you have to submit a few times or something. In 116, we're going to focus on how do you determine if your code is correct, which is what you ultimately have to do by the time you get out there in industry. Nobody's going to be there holding your hand and saying whether the code is correct or not. You're going to have to determine that by yourself. Sometimes you'll have other team members who can help you do that, but at some point you have to be able to just write code that does a thing and have confidence just from within yourself that that code is right. And a big way that we do that in programming is unit testing. We're going to write tests to automate the testing of the software and make sure that it returns the right output on particular inputs for the most part. We're also going to learn a lot of OOP. I'll call this classes throughout the semester. Just to be honest, it worked better alphabetically with C comes before D when things are sorted alphabetically. That's the only reason I call it classes. But it's really OOP, object-oriented programming. This gives us a way to organize our programs when they do get larger. If you coded in the CS1 way, you would really have trouble organizing things. You would likely have a couple of really huge functions that would be doing most of the work, and it would get unorganized pretty quick. OOP gives us a way to organize our code and also reuse code. When we write code, we want to write code one time and then reuse it throughout our program. That's the whole idea of writing functions to begin with. We write a function one time, we test it one time, and then we use it throughout our whole program. OOP is going to take that same idea but leverage it and take it to whole new lengths. And then data structures and algorithms. You know what data structures are. If you're in this course, you know, depending on what language you're coming from. If you took 115 at UB, what's up, Gurley? If you took 115 at UB, we taught Python and JavaScript. We're cutting JavaScript, so soon it'll just be Python. But in Python, it would be list and dictionary. In JavaScript, it would be your array and object. If you did come from Java, by the way, this course will be taught in Java. If you're coming from Java, it's probably array list and hash map. Those are the big ones that we'll start with this semester. C++ would be vector and I think it's map for a key value store. But you're used to at least two data structures in whatever language you come from, hopefully at least. A key value store and a sequential data structure that's accessed by index, getting values by index. And some algorithms to work with them, sorting, finding elements, things like that. The data structures we'll focus on this semester. One, we'll start with array list and hash map, but I'll just assume that you know how to use those. I'll show you the Java syntax of how they work, but those will be our sequential and key value store data structures. And we're going to expand that with linked list, trees, and graphs. And as I won't just read the line, but we're going to focus on how our programs work. In 115, your CS1 course, you just care that the code does what it's supposed to do. And that's good enough in 115 in any CS1 course. It's not good enough in 116. We want you to understand how the programs work. A big aspect to that we'll talk about as I get through the syllabus is drawing memory diagrams and tracing through exactly what the computer does when it executes your code. and what exactly is stored in memory, how memory works, everything about how the program is actually run. Right, I'll take a quick side note. So I did shout out Gurleen. So Gurleen is our one TA this semester. I'm limited to the TAs I can hire for the semester. So Gurleen, when you see Gurleen in chat, Gurleen is a TA, so feel free to ask her questions. She might be watching chat every once in a while. She is on the other side of the planet right now, so this is not a convenient time for her to be in lecture. She might not be in every lecture, but she will be in office hours. Oh, Gurleen, get your office hours on the schedule too. Actually, I skipped that whole part of the lecture, the syllabus. To go through the links here. YouTube, if you're watching this, you found that. Hopefully you found this one, and you know what that's all about. Autolab, if you're not from UB, Autolab is where we submit programming assignments. But Autolab is an automated grading tool that we're going to use to submit your programming assignments. It will automatically grade them, usually in about 10 to 15 seconds. For some of the more complex assignments where the grader has a lot to do, it takes more like 30 seconds, but quickly, within a minute, you're going to get results on that submission, and you can submit as many times as you want to Autolab, before the deadline, of course. So as many times as you can submit, you can keep getting feedback and then resubmitting. Hopefully I recommend not abusing that. Students do, but to the end of unit testing and knowing that your code is correct without the system is one thing that we need you to learn in 116. So Autolab will be testing your testing in addition to testing your code. But yeah, students do tend to submit a lot. But you're allowed to submit as many times as you can. It's not something I'm going to police or control, but if I see a bunch of submissions and you're in office hours, I might be like, dude, test your code. Oh, it's only 6 p.m. there? You made it sound like it was going to be a lot further off. Cool. Carly, help me debug my code. I'll show code in the slides in lecture. Whenever I show code in the slides in lecture, it'll also be in this GitHub repo. You can go here and take a look at all of the code that'll show through lecture. It is set up as a 14-week semester, but if you read week as lecture, it'll be weeks 1 through 9 are going to be what we'll cover this semester. And then 10, 11, 12, 13, 14, it's one of the things that just has to get cut to fit this in a 6-week semester. You're more than welcome to look at that code. I'd be happy to talk about those concepts in office hours if you're interested, but there won't be... Oh, actually week 10 is... Oh, I was off by a week. Week 10 we do cover. Starting with week 11, we don't cover things. Week 10 is graphs. Graphs is really important. Week 11 is going to be advanced testing techniques. I might cover a little bit of that, but weeks 12 and 13 and 14, those I won't touch at all. So, for better or worse, some topics just had to get cut. Memory diagram reference, this is going to mean a lot to you. I usually say later in the semester, but we're going to start memory diagrams today because we just got to go so fast. Memory diagrams, this is going to be what you'll be doing on your quizzes. So each quiz, you're going to get a sample piece of code, and then you're going to have to trace through the stack and heap memory and exactly what the computer does when it executes this code. So we want to draw, let me get to one with a heap in it. We won't get to heap till Thursday, I guess. It goes fast in the summer. But this is how we're going to draw our memory diagrams. What values and variables are on the stack, what objects are on the heap, and how everything interacts with each other in what's printed to the screen. That's the idea of memory diagrams in just one sentence. That'll mean a lot to you throughout the semester, and that is something we have to do on the quizzes. Piazza, this will link to the... I think it's... Oh, I'm not logged in. I think it's safe to go here because there's no private posts yet. But this is our office hour schedule. Office hours are going to be on Zoom. My first office hour today, 2 to 3. I might, depending on how I feel after lecture, if I need a break or not, I might just hop right over there after lecture at, I forget when lecture ends, 1:40. It's on my whiteboard. I had to cheat to know when lecture ends. 1:40. If I'm going past 1:40, make sure someone stops me. I meant to set an alarm on my phone. I'll do that for the other lectures. Gerline, as she just said in chat, she'll get her office hours on here as well. But, it's the first day. We're still working out our schedules, which we got to do pretty quick because, it's only 6 weeks. And I'll add, I don't know where I want other office hours. I might just do after each lecture. I haven't fully decided yet, but before we get to the point where I would have office hours, I'll update it. And this is a dynamic post. If we want to change our office hours, we'll update this post. So check this. We'll try to give enough notice if we're changing our office hours. But we'll have. It's still summer. Like we'll have other things going on and things like that. So if I put an office hour on Monday or Friday, and I have a long weekend with family stuff, I might have to change that. So make sure you're checking the post before you go into the Zoom meeting. Okay, and Discord. I don't know how important Discord will be over the summer. I guess it's never really important. But, oops. Oh, and Piazza is where you can, if you haven't used Piazza before, you can ask questions. You can add a post, say, I need help with my programming. And if you do, please follow this guide to getting better answers on Piazza. Make sure in general, the more information you can give us, the easier it'll be, the more help that we can give you in a quicker amount of time. If you make a post that's just a screenshot of your code that says help, which a surprising amount of students do, we're probably just going to respond with @7, which is a link to this post, and then ask you to write a better post so we can actually help you. And that partly depends on how, again, there's only 2 of us, so it depends how flooded Piazza gets. If we get a lot of questions and you're giving low effort posts, we're just going to @7 you because we ain't got time to answer everything, especially low quality posts. So Discord, I've been running this Discord in my classes for quite a while, for years. I think pre-COVID, I've been using this. So there's a lot of students in there, a lot of alumni still hang out in there. So there's a lot of people in there that you can just chat with. You can, ask questions and, just hang out. There's nothing official. Oops, I keep hitting the enter button. There's nothing official that I'll do in Discord. I might be in there from time to time. Gerline might be in there. But we're not in there at any official capacity. We're not there as professor, as TA. But we might go there and hang out and stuff. So don't expect us to answer coding questions or questions about the course unless they're general questions. And I always tell my TAs that they can ignore DMs from students, and I typically ignore DMs from students as well. If you're DMing one of us on Discord, you're doing it wrong. Just go to Piazza and ask a question there. When you do ask a question on Piazza, make sure you... Oh, I don't remember how to do this. Right here. Make sure you make it private to instructors, especially if you're including code. If you want specific help on your code, make sure you make it private to instructors. That'll make it so only Gerline and I can see that post, and you're welcome to share your code then. If you're sharing your code publicly on Piazza to the entire class, that's clearly, and I'll talk about this a little more later, but that's clearly an academic integrity violation, which can get you a real quick F in the course. Don't post your code and share your code with the entire class. All right. Y'all got questions, and I like it. No interviews. The quizzes, I don't know about quiz logistics quite yet, but no interviews. Interviews is another thing that has to get cut. Again, only 2 of us in 6 weeks, trying to give enough interviews for everyone. We just don't have the time to do it all. So unfortunately, it's got to get cut. I don't know how I feel about that quite yet, but just logistically speaking, we can't really do it. All right, so I already touched on this a little bit. This is not an easy course, and it can be very easy to fall behind in this course. The expectations for hours are a little bit different, obviously, because it's a 6 week instead of a 14-week course. But the math works out to 24 hours per week that I would expect each and every one of you to spend on CSE116 each week. This includes 9 hours of lecture. I'm rounding up a little bit there. There's, I guess it's 8 hours total. But like 9 hours of lecture, which leaves 15 hours per week outside of lecture, which is mostly going to be spent working on the programming tasks. Sitting down and writing your code. And of course, some of that will be studying for the quizzes, practicing your memory diagrams, rewatching lectures if need be. That's the amount of time I would expect. Judging from and this is a minimum, judging from the past, just talking to enough students about this, it's possible, feasible, that some of you will put in 24 hours per week and still fail the class. It is extremely, and I don't want to say that to scare you, I just want to, I do a little bit. But I say that to really drive home the point, and I'll do this a few more times today, that you can't fall behind. You can't fall behind when this is a 14-week course. I harp on that a lot when it's a 14-week course, 15 with finals week. And that students can't fall more than a week behind. Once you're more than a week behind, it's almost impossible to get caught up in the course. So translating that to this summer session, if you fall one lecture behind, you're probably not going to get caught up. Like I just want to tell it like it is. If you're falling too far behind, it's going to be hard to get caught up. Unless, of course, you're making it as a full-time job to get caught up. You're trying to do 2 weeks in a single week, and you change this into a 48, you can potentially make that up, but you're also going to drive yourself insane. I assume you want to be here. You're taking a second course in CSE. The first course didn't scare you away, so I assume you want to learn about computer science. And you need to be comfortable with all of the material in whatever your CS1 course was. If you took it at UB, it'd be CSE115. But you need to be comfortable with all that material. If you did take it at UB, there are a few things that you actually don't need to that you won't need from 116, the material that is being cut from 115. That's the web stuff, the database stuff, anything with JavaScript. Those things, the security stuff, those things I won't rely on for 116. But all of the basic concepts, functions, variables, data structures, control flow, your conditionals, your loops, all that stuff you need to know inside and out. All those basics, those fundamentals of programming. So we're going to go through pretty much all that. I think we can get through all of it today in Java, and then starting Thursday, we're going to start learning new material. So there's not going to be a lot of 115 review this semester. I'm going to expect you to know those concepts and be able to transfer them over to Java very quickly, as it turns out, in 2 days. And if you need help reviewing CSE 115, I have some links here for some practice, so feel free to take advantage of that if you're wondering what I expect. It's roughly modules, like if you go to UB Infinite, it's roughly, it's roughly modules 1 and 2. So if you practice those two, we won't do much module 4. We actually will do custom sorting, but the way I covered it in 116, I don't rely on prior knowledge. Writing files we won't do. Reading files we will. I guess I don't have a reading files thing on here. All the web stuff, the JSON stuff, none of that's going to be required. But modules 1 and 2, oh yeah, reading files is right here. Reading files, all this stuff. Objects, dictionaries, arrays, lists, your data structures, your variables, your functions, your conditionals. Didn't see loops in there. Loops got to come with arrays and lists, I would assume. Am I going crazy? Where are loops? Well, yeah, they got to come with the lists and arrays, I would have to assume. Oh, I'm not going to mess around with it right now. Alright, now let's get into what we're going to be doing on for the course. So, the grading of this course is different than most courses out there. And as it turns out, it's different even from a fall or spring 116. Again, some changes need to be made. So there are learning objectives in the course. There are 14 total things that you'll need to complete, and you need to complete every single one of them to pass the course. You have to complete all of these. The reason for this is there's the things that we're going to cover and the things that we'll ask you to do. It's going to be programming assignments and quizzes. They are fundamental to your computer science knowledge, and if you don't know all of this material, you're not going to be able to move on to the next course, or rather, if you moved on to the next course, you wouldn't be prepared for the next course, and then you would just fail the next course and never go back. What students do is if they pass but don't know the material, they'll get stuck in a loop where they can't pass the next course, but they're never going to go back to the previous one and learn the things that they missed in 116. So to account for that, to hopefully make sure everyone who passes the class is prepared for the next semester, you need to complete all the learning objectives of the course. There are two primary categories which map to the two of the three major focuses of the course, the foci, OOP, and data structures. And they're going to be assessed through reading, which is the quiz, drawing the memory diagrams, and writing code. So read and write code, that's what we want you to be able to do. Notably, those of you who are familiar with 116 in the fall or spring, there are no interviews. We used to have read, write, and explain. Now it's just read and write to fit into the summer class. Write is also going to include writing unit tests, so that's where the testing portion from earlier comes back in. With OOP, the main topics are classes, inheritance, and polymorphism. With data structures, the main topics are linked lists, trees, and graphs. So we have six kind of categories, I guess, like six main concepts that you need to understand before moving on from 116. And to assess these, our learning objective completion, there are going to be 6 quizzes which map exactly to those 6 topics that I just listed off. These quizzes are going to be during, I have the word lab. If the word lab creeps up, I just missed that word. Quizzes used to be in the actual lab sections of the course, but we don't really have labs anymore. We just have 2 kind of lecture sections. It's weird how they set up the summer course. By the way, I'm gonna treat 11 to 240 as one big lecture because that's as much time as I would have in a week of lecture, and I only have 12 of them instead of 14. It's weird that they don't give us an actual lab section. Usually you'd have 4 extra hours per week of instruction time in the labs. We don't have that, so we have to put the quizzes in lecture, and they're going to be at 11 a.m. on 3 certain lectures. And here's where I got to explain all the grading. So this always takes a little bit because it's not just quizzes are 20% of your grade, homework is 40, final exam is whatever. That grading structure is really easy to explain. So this is a little bit different, and it seems very harsh at first where you have to complete everything in order to pass the class. So let me explain it all. So 6 quizzes. These will be in 3 different lectures, and they'll come in pairs, like Classes 1 and Data Structures 1. We'll give you both those quizzes in the same lecture. It'll be 11 to noon Eastern Standard Time, and you'll be able to do both of those quizzes on that lecture day. Then there's a day for Classes 2, Data Structures 2, Classes 3, Data Structures 3. These are graded on a pass-fail basis, where you'll pass as long as you haven't made any large fundamental mistakes. These are graded by humans. They'll be graded by Gerline, and myself if I have to jump in as well. Depending on how all the logistics go. But they'll be graded on a pass-fail basis. If you've demonstrated that you understand the learning objective, you completed the learning objective, and that you can trace through the execution of programs that use linked lists, trees, and graphs using memory diagrams, if we believe that you've completed that learning objective, and the criteria for that is that you didn't make any major fundamental mistakes that show a misunderstanding of the concept. That's our rule of thumb. Yes, there is some subjectivity in that grading, but that's our rule of thumb for the pass-fail basis. And you have to pass all 6 quizzes to pass the class. Sounds very harsh at first, 1 mistake and you fail. So there is, I don't know where it is in the text right here. Let me find. right here. So there is a fourth day for quizzes. It's going to be the very last day of classes, which is effectively our final exam, but I don't call it a final exam at all in the syllabus. But it's going to contain all 6 quizzes. So if you didn't pass even potentially any of the quizzes on the first time that they came around in those 3 separate lectures in the 11 to noon, the last lecture from 11 to 2:30, you're going to get all 6 quizzes again, and you would take any ones that you didn't get the first time around. So any of the ones that you did not fail or did not pass, you have that second chance on that final exam, that final day. And if you passed all 6 of them the first time, guess what you're doing on the last day of classes? Whatever the hell you want. You can do whatever you want. I don't care. You already passed everything. There's no need for you to be there. So if you pass them all in the first shot, you're done after 11 lectures instead of 12. Assuming you got the tests done. Of course, you got to do the programming tests too, which we'll talk about. So you get 2 chances, and that's still, in my opinion at least, that's still a bit harsh. That you only get 2 chances and you have to complete all 6. So if you at least have 4 of them completed after your 2 attempts, I'll give you a chance to finish the last 2. Those will have to be scheduled outside of lecture time because we will be out of time by that point. But I'll give you a chance to make up to 2 additional quizzes after the final exam. And we'll be in touch. We'll schedule that. We'll figure out the logistics of exactly how to get that done. But I'll give you another chance. As long as you got 4 of them complete and you're within 2 of passing the class, I'm going to give you that extra chance to get those last 2. Those of you familiar with the regular semester 116s, that's effectively 2 recovery opportunities, but I'm not going to use that terminology this semester. And then the programming test. And these will all be memory diagrams. These will be, here's code that uses classes, trace through, stack, and heap. Here's code that uses linked lists, trace through, stack, and heap. Show me exactly what happens when this code executes, which is a very important skill when assessing, do you understand how your programs work, not just that they work, back from the, basically the tagline of the course. This is, do you understand how your code works? And that's what we want to get at with the memory diagram, with the quizzes. And then 8 programming tests. These are a bit easier to explain. They're programming tests. You program, you submit to Autolab. When Autolab says you're good, you're good. If Autolab says you're not good, take the feedback from Autolab and fix your code. Come to office hours, ask on Piazza if you need help, if you get really stuck. These programming tests let me scroll down for just quickly here. These programming tests are listed on the course schedule on the week where the content is covered. So programming test 3 is about linked lists. It's listed right by the linked list content, because this is all the content that you're going to need to be able to complete programming task 3. And then the programming task, what I call expected deadline, is going to be 1 week after that. So this was Thursday, June 8th. Hopefully I got all the dates right here. Thursday, June 8th, Thursday, June 8th. So then 1 week later, Thursday, June 15th, is going to be the expected deadline for programming task 3. So 1 week after the content was covered, minus a couple hours because I put the deadlines at 9 a.m. So you're not, students tend to do the homework during lecture. So I want them to do a little bit before lecture, so you're not panicking to get them done right during lecture. And then you don't pay attention to the new stuff. If you're doing task 3 during inheritance lecture, you just completely missed inheritance. So students, I've seen too many students fail because they were using that strategy. So I just don't let them use that strategy anymore. Simple enough. Alright, so programming tests, you do have to complete all 8 of these as well. You have to complete all 8 programming tests. You can't just call it and be like, I don't want to do this one. I'll just take the hit to my grade, because that hit is an F in the course. So all 8 of these you have to complete, but you don't have to complete them by the expected deadline. There is the actual deadline. Do I call it actual? Yeah, I did call it actual deadline. The actual deadline, the deadline for all the programming tests, is the day after the last day of class at 11:59 p.m. Eastern Standard Time. All times are going to be Eastern Standard. So whatever translations you have to do. After the last day of class. So that Friday after the last day of class, that's when you have to have all 8 programming tests done. Because at that point, I got to get final grades in. Like, I kind of can't extend these anymore. If you're 1 or 2 programming tests away, I don't have anything official in the syllabus for that, but there's the potential I could give like a few more hours or an extra day or so. I'll treat that on a case-by-case basis. If you're really close to passing the class and you've gotten most of the content that I needed to get out of the course, and you're just struggling on one piece of one programming task, like, I do want to push you over the finish line. So I'll work with you. We'll, email me. We'll talk and see what we can do. But I'll do that on a case-by-case basis. Inquiring minds want to know, I am taking 191 right after this class at 2 p.m. Yeah. Oh, that's... They let you register for that? I mean, that'll be fine, but you have to catch up on what you miss. So each lecture, yeah, it's going to go from 11 a.m. to 2:40. I do have that right? Oh, 1:40. Sorry about that. 11 to 12:30 and 12:40 to 1:40 is how it was listed. Okay, yeah, I just had that messed up. 11 to 1:40. It's almost 3 hours, right? God, I hope so. 11 to noon to 1. Yeah, almost 3 hours. Yeah, not almost 4 hours. I don't want to do 4 hours straight either. Yeah, so 11 a.m. to 1:40. Sorry, I misspoke with that one. I'm going to treat it as one big lecture. The reason I said this is because there's that 10-minute gap in between. I'm just going to plow right through that, and I'm not going to treat it as like lecture and lab. If it's your own... Okay, so yeah, this comes up every semester, so I gotta make sure I address this. Sorry, I've been focused on what I was saying, so I make sure I'm answering the right question. Okay, so according to the university, if you use work that you've created for a separate course, that's technically an AI violation. That is something that I do allow in my courses, though. So I do kind of turn a blind eye to the university policy on that one. If you wrote, if you've taken 116 before, as long as you wrote that code for 116 in a prior semester, and you want to resubmit it to the tasks, like I released tasks 1 through 3 already, and they're identical to last semester. I'll just be upfront about it. They're identical. I had 1 week in between semesters. I ain't sitting there changing everything. Some of the later ones will have to change a little bit. But some of them will just be the same. As long as you wrote the code, you can resubmit it in this semester. But it has to be your code that you wrote. I have had issues in the past where somebody committed AI, failed the course because of that, and then resubmitted the same assignment again. Well, that assignment's already out there. Like, other people have that code, and then once somebody else in the summer also submits that code, or any later semester, you get another AI violation, and you're screwed. It's got to be your own code, and it has to be code you haven't shared, that's not out there available to, whoever your asshole friend shared it with, because they're clearly got you caught. So be careful of that one. But if it's code you wrote and it's not out there, so it is. I go back and forth on this a bit. I do allow it still, but whether I should or not is something I don't know. I think I'll still allow it. The problem with this is my issue where if I say no, you can't reuse that, there's a strong possibility that the same student doing the same assignment, their code's just going to look similar. It's going to have their same style. It's going to look similar to what they've submitted in the past. And when that comes up on my MOS checks, what do I do? Well, I mean, the student just has that style. They created the same thing twice. And I do this in lecture. I have live coding demos in lecture. And from lecture to lecture, I do it live. I just have the idea of what I'm going to do, and then I just code live. Like, each semester, my code looks very similar to what I did the previous semester. So if I'm even doing that to where I could get caught with AI just because I did write the code again, but it looked similar enough that that a plagiarism detector would detect that, I don't know how I can do that to students. It just doesn't. I just don't have a good way of saying, did you actually type this up again? Or did you take your old code and type it and make a few changes? Then, I don't know. It gets spotty. So it is self-plagiarism, I guess, if you count that as a bad thing. But I do allow it, is the short answer. There's one more thing I was going to say about that. And because I think that's a university policy, because it makes sense in other courses. If this were an English course and you were writing essays, I would just say, no, you can't use your old essay. That'd be absolutely ridiculous to use your old essay. I would ask you to pick a new topic, and then you'd write a new essay on a different topic. You can't use that same essay on the same topic, because it's easy for me to just say, choose something else. No, you can't use the same topic. That's ridiculous. But when it's programming assignments and I'm not changing my assignments, I think that's on me. If I want to prevent that, I would have to make all new assignments every semester, which would take an absurd amount of time. I used to do that, and I almost burnt myself. I did burn myself out, actually. So I usually try to change at least one or two assignments to make sure that the student isn't just completely cut and pasting. All right, so that's the programming test. They're all due the day after the last day of classes, but there are expected deadlines. That's where I would expect you to have that task complete, which are probably a little generous given the pace of this course. It should be before the next lecture, but when it's a Tuesday assignment, I'm not going to make it due Thursday, 2 days later. So I give the full week still. Okay, so complete all 8 programming tasks and all 6 quizzes to pass the course, and then your grade will depend on something called application objectives, which I haven't mentioned yet. So let's mention those. If you get 7 programming tasks and 6 quizzes, or 8 programming tasks and 5 quizzes, anything less than all, it is an F in the course. So make sure you're getting all these things completed. But there are, several chances on each. The programming tasks are due at the end of the semester. I think there's enough chances where if you are putting in your 24 hours a week, I think you'll be good. All right. Then your grade will depend on application objectives. Here's the breakdown. I'm not just going to read the chart, but if you get 0 application objectives, you can still fail the class. You do need to get at least one of these things to pass the class. But I did get rid of D's, so if you're passing, you're at least getting a C-. All right, so application objectives, pretty straightforward this semester. These get pretty complicated in the fall and spring, but they're pretty straightforward here. If you meet a programming task expected deadline, you just earn yourself an application objective. So that's the reason for those expected deadlines. This is my incentive. And by the way, all the application objectives are designed to encourage you to stay on top of the material. I really want you to stay on top of this material. Again, I believe if you fall one lecture behind, you're going to significantly increase your chances of failing this class. So the application objectives are designed to encourage you to stay on top of things. So if you meet those expected deadlines, you're improving your grade, assuming you do complete all of the learning objectives. So there's 8 expected deadlines, but I'm going to cap this at 6. So you can complete, for each expected deadline met, you get an application objective up to a max of 6. And then quizzes, a max of 4 on this one. If you pass the quiz on the first opportunity, that's another application objective. So that encourages you to study and prepare for that first chance quiz. If you pass it that first time, that's an application objective up to a max of 4. So you can't get all 6. I'm going to cap it at 4. The reason I'm capping it is to give you some flexibility. If you, like the first 2 quizzes on that first quiz day, you just didn't understand memory diagrams yet or whatever, something happened, I don't want you to be punished for that. So I cap it to have you, allow that one bad quiz day, still make it up on the final day of classes, and not be punished in any way. Same with tasks. There's going to be a task or two that just kind of comes out of nowhere and kicks your ass. I don't want you punished for application objectives, so you just couldn't earn those ones to begin with. And there's also there's kind of a twos theme here. Two capped at number of expected deadlines -2, number of quizzes -2. And you can miss 2 application objectives and still get an A. So in an A, there's 10 total available. Miss 2 of them, you still get an A. So somewhere in here, find your 8 application objectives. And then once you complete all of the learning objectives, you'll get an A in the course. I believe my expectation with this structure is that as long as you're keeping up with all the content in the course should feel more like a pass-fail course, where you do everything, you get everything done on time, you get those quizzes on the first shot, you're doing your tasks when you're supposed to and getting them done within a week. You either get an A, you complete everything and get an A, or you don't complete anything and get an F. And hopefully, I hope, that most of you will be getting the A's. So I think it's more like a pass-fail. You either get an A or an F. We'll see how it works in practice. But that's kind of the intent of this. Just stay up to date on everything. Keep doing things as they come out. Don't stockpile the lectures and try to watch 2 lectures in a single day and things like that. Don't do those silly, terrible time management things. And I want to see you pass everything and get an A in the course. All right. There's no textbook. And then takes us to AI. If anything, any of these relate to you, well, grades, I guess, relate to all of you. If you need counseling, seek help. If you're going through anything, don't try to go through it alone. We have counseling services that can help out. And if you have any issues with accessibility, they're there as well. Especially if you have any documented disabilities, they'll help you out. They'll give you accommodations, whatever you need to help you still succeed. And then academic integrity. Here's links to the 2 relevant policies, but I'll just read the parts that are specific to this course, my course policy. So if the main way that I do academic integrity checks, or cheating checks, if you want to call it that, is by similarity of code. So we have software that we're going to run. It flags any code any 2 submissions that are sufficiently similar to each other, and it'll give me the similarity percentages and all that stuff, all kinds of information. Then I go through and manually review all those to make my informed decision of whether or not academic integrity a violation occurred. If I decide a violation has occurred, all students involved get F's in the course. I don't care if you're the one copying the code, or if you're the one giving code to your friend, or if you work together and we're sharing code while you're working together. I don't care how it happened. If 2 submissions are too similar, where I don't believe that it could happen by pure chance, it's an F in the course. 1 offense, F immediately. I'm not going to mess around with zeros on the assignment or anything, which in this course, a 0 on an assignment is still an F because you have to complete them all. So it won't even matter, to be honest. And if you have any questions about this, if you come to me before I catch you, I've never failed a student who came to me before I sent them an email and said, hey, we got a problem. I'm not going to fail you if you come to me, hey, this thing happened, what do I do? Oh, I accidentally gave my friend my code, he pressured me into it, like I didn't mean to do it, but now they have my code. Like, I'll work with you on that one. We'll figure something out. But once you get caught, once I send you the hey, we have a problem email, it's over. There's no saving you after that one, unless you actually have a legitimate excuse, which is very rare, but it happens. Very, very rare. It's usually a case of stolen code without one person's consent. So there are a lot of things that are allowed. You can discuss abstract solutions at a high level, like how you're going to approach a homework. That is allowed, as long as you're not writing the code together, as long as no code is shared, and as long as the level of help has nothing to do with how the code is going to be written. then that's allowed. I do want you to be able to form study groups and talk to each other, work together, but you have to keep it at that abstract level. You can't start talking about the actual code that you're going to write. At that point, you're crossing the line. In general, if somebody can see your code or you can see somebody else's code, that's a violation. Whether you get caught or not, whether it's egregious enough for it to come up on my detection tools, that's one thing. But it is technically a violation. As soon as somebody can see your code or you can see somebody else's code, that's a violation. And even sometimes when that's not the case, if you're explaining the code but to a level of detail that your code's going to look similar, it's still a violation. Forming study groups is fine. Searching the internet for extra help, that's always fine. But make sure you understand how it works and not cut and paste it into your code. I see that way too often. Obviously, you can come to Gerline and to myself. Hiring somebody to help you with the concepts is fine, but keyword is concepts here. I should probably bold that one because I have so many students in the AI meetings that say, oh, I hired a tutor and they just helped me out a little bit. No, they didn't, because look at this code. And then unacceptable behavior. In general, it's submitting any code that is not your own for course credit. Everything this semester is for course credit, so that clause doesn't really need to be there. But submitting code that you didn't write, that is a violation, period. Using an AI to assist in writing your code with ChatGPT, this is becoming a bigger deal, and we're developing ways to look for that and detect that. I want to make sure I point this one out because it is by far the most common type of violation. Of course, ChatGPT is making a run for it. I might have to move this arrow up here pretty soon. But writing code together, I see this all the time. Like, students will do it right in front of me in office hours. When we have live, like, in-person office hours, they'll sit next to each other. Their two laptops are, they're sitting side by side. The two laptops are out and open, working on the code, and they can clearly see each other's code. And they're sitting there working, like, line by line together. And they try to explain it like they didn't share code, they just worked together. But the way they work is, okay, what do we do on this line? What do we do on this line? What do we do on this line? And just line for line, their code ends up almost identical, and it pops, hits the top of my detection tool, the top of the list every time. And they're like, oh, we just worked together, we were both really trying to learn, which I tend to believe, but if you need somebody right there working with you, I don't have the confidence that you learn the material, that you've completed the learning objectives, and then you can do the assignments on your own, which you need to be able to do to pass the class. Allowing another student to, I won't go through all these, but these next two I want to make sure I highlight. Allowing somebody else to see your code. You do have the responsibility to control your code. Some of the common violations are roommates. I guess that's less of an issue this semester. But roommates where one of them will leave their laptop, they'll go to the bathroom or whatever, and their roommate comes in with a flash drive, gets all their code, goes back to whatever they were doing, and you have no idea that that just happened. You do have a responsibility to control your code and not allow other people to see it. I see this in office hours too. Sometimes someone will run to the bathroom in office hours and somebody will grab the code. It's a bold move, but it happens. And then the other ones, you can't hire someone to write your code. These all fall under the first one though. Nobody's tried this in a while, but I'll leave it on there. In copying large amounts of code found on the internet, this one, like, a lot of times you can get away with this one, right? Like, you find the solution online and you just use that solution. But you can't get away with that if any other student in the class also found that solution and submitted it. Because now it comes up on my similarity detection tool. I don't even have to know or care where you got it from. I just know that two of you got it from somewhere. Or that one of you got it from the other. I don't even care. It's a violation. It's F's in the course. So copying material off the internet, you have to trust everyone else in the course is not doing that same thing. Which is a bold assumption, and usually those students get caught. Alright. So I'm not going to do breaks necessarily, but it'll take a second to catch up on chat. I don't think I missed much here though. But we're done with the course introduction. That would have been the first lecture, and I'm hitting my time at 11:50. So it's good my timing's still intact. Is IntelliJ the website we use to write our code? It's an application. So IntelliJ is this application. You'll want to download this and use this to write your code. And I should have time to do I'll find time actually, to do an IntelliJ demo by the end of this lecture. But it is software. You have to download it. IntelliJ, you have to download this. I recommend downloading Ultimate. Community will get you through the course though if you don't want to mess with Ultimate. Ultimate, I guess the free trial would be long enough to get through the course, right? But with your educational license, so you get an educational license, which you can get because you have a .edu email address. Get your educational license, and you can get all of JetBrains software for free. So you can get the Ultimate Edition for free. It doesn't expire. Every year you have to renew your educational license, but it's not a big deal. And use that. It just has a few more features. Not necessarily anything we'll use this semester for the new features, for the extra features. But it'll be something that you might want in later courses or later in your career. Those features might come in handy. So just getting it set up now can be helpful. But it is software. You have to download it. I suspect that the first week of office hours will be a lot of helping you get IntelliJ set up. There's always little things that go wrong and get weird with IntelliJ setup. All right, let's get right into it then. Let's talk about Java. All right, I was having this problem when I think I just closed it actually. So I can do this by going into File Explorer, but I want to figure out the best way. I guess I can just do it that way. I want to opens with Ocular. So I have it set, yeah, and it has the symbol there, but how come I download it here? Do I have to open it? No, that's going to be... But when I double click this, it just opens in Opera. That's dumb. That's not my... It's not the default application I want to open it. Ocular has a good slideshow. Oh, and it didn't do it because I already had it open. Ocular has a good slideshow thing for doing this presentation mode for doing PDF slides. I just have my slides on PDF, so you don't have to download any extra software to review them. And I like presenting from the same slides that you have. Any options or features to enable? If you just have the basic community edition of IntelliJ, that'll give you everything that you need for this course. You'll have everything that you need. There are some plugins that are helpful, but they're all default plugins that just come with the base install of IntelliJ. But IntelliJ does have a really good plugin system if you want to look for more, but nothing in particular that'll help you with 116. Just base vanilla IntelliJ is good. Check always use this application when opening. Did I thought I was doing that. And then does it give me, that didn't give me the option. Ocular. I ain't gonna mess with it. I'll do it off stream. I'll look at it. Either that or I'll just complain every lecture. More likely what I'll do. Alright. Java. My neighbor's mowing his lawn. Hope you can't hear that. And windows are closed, but still, it'll be fine. All right, start with Hello World. Where else would we start? All right, so this is the simplest Java program we can have, and it's still pretty complex. So there's a reason why we don't like Java in our CS1 courses, though in high school they still use Java for AP CS. I don't know why. Maybe they just don't want to change everything. It would be a pain in the ass to change it. But anyway, Java's not great for first language because this is day one. What you have to start with is all of this crap. So it's pretty complex. But let's break this down. It's just going to print Hello Java to the console. So let's take a look at every piece of this program so we can understand what's going on here. So first, we have a package declaration. Package week 1. And again, this is out of the repo. You can clone that. We don't know what that means yet. But you can look at that code. We'll do a cloning exercise after this. But you can clone the repo and access all this code. And you'll see that this is in package week 1. And that's going to correlate to the directory where the file is saved. So we have this source directory, src for source, short for source code. The source, and then in the directory week 1. So everything in the source directory, that's like our base directory for all of our code, called our sources root. And then week 1 is going to match the directory here, week 1, is going to match the package week 1. So your package declaration, you can think of this as the directory where this code lives. Yeah, APC, I don't know why they do it in Java. It's too complicated. And they get into like a lot of OOP concepts too, which I guess you kind of have to if you're doing Java. I would redesign that if it were up to me. But then they got to change all the AP exams, and they got to do something with the old ones. I don't know. It'd be a lot of work to change it. It's too big of a system, too bloated of a system. Changing a language in a course is hard enough. Changing it statewide like that. Or is it statewide? Is that or is that nationwide? And then the class name. So we're going to create a class. Everything in Java is in a class. Everything happens in a class. It's the only way that we can actually get code to run. Well, technically, but it's the only way we can get code to run is in a class. There are other things that we'll see called interfaces that behave kind of like classes, but a little different. But everything needs to be in a class. The class name, Hello World in this case, has to match the file name of our code. Oh, national. Yeah, that'll never change. That's going to be way too big of a system to change. They might be stuck with Java forever. So Hello World is the name of our class. So helloworld.java is going to be the name of the file where this code lives. So our class name has to match our file name. And all the actual code is inside the class. We can't have anything else out here except our package declaration and our import statements, which import we probably won't get to today. I was hoping to try to take a little bit of Thursday's content, cover it today. I don't think that's going to happen, though. I think my timing is at this 50-minute mark where it needs to be. I don't think we're going to be able to get ahead at all. So if we put these two things together, this class Hello World is in a file called helloworld.java. And the package declaration tells us that we're in a directory named week 1. And all code is in the directory src for source. So this code is in a file source/week1/helloworld.java. That's the full path for this code. Called the fully qualified path, but I'm never gonna quiz you on what that's called. But it's helpful to know if somebody else says fully qualified path. That's what they mean. All right, and then we have this main method. So the main method is where all of your code starts. This is where your program starts. If we run this Hello World file as a Java program, what we're actually doing is calling the main method. So this is the method that's going to be called, and I'm going to say method throughout the whole semester because this is Java. But method, I do have a bullet point for it. A method is basically a function, but it's a function that's defined inside a class. So when I say method, if you hear function, I'm not going to get mad at you at all for that. But I'm going to do my best to stay with the accuracy, the accurate what it actually is, and it's defined in a class, so it is a method. Everything we talk about is going to be methods. We're never going to see a function all semester, but methods behave very similar to functions. So if you're only used to functions and I say methods, if you just think functions, I'm not going to get mad at you. But you're technically wrong, but it doesn't matter that much. But I feel like I should be right if I'm teaching this stuff, so I'll try to stick to the right thing, which I've been good at over the years. I don't think I've misspoken years on this one. And yeah, like I said, running this program, this is technically a full program. We'll call the main method and then just print hello Java to the screen. Oh, we didn't get that far. Now, there's a lot of extra words here. This public, which I haven't talked about yet, static, void, string, args, a lot of stuff I haven't talked about yet, so let's fill in some of the gaps before we get into the last line, which I guess I don't have much to say about the last line. Static for the first two lectures, everything's going to be static. And then on lecture 3, when we introduce classes, I know we have classes here, but we're going to actually talk about classes proper. Then things will start being non-static. Right now, everything's going to be static. And what we need to know for now is that we can call the method without any extra steps. Now, those extra steps, a week from today, those extra steps are going to be instantiating objects based on classes, using classes as templates to create objects, and then calling methods through those objects, which are instances of the class. When we use static methods, we don't have to do any of that yet. We don't know what objects are yet, so we're going to have all static methods for now. So static means we call it without creating objects, which we don't know what they are yet, so we can't do that. Other than call and invoke. Oh, I have to study call versus invoke, that vocab. I always treated those as the same. I might have to look into that one. But yeah, method means it's part of a class. And then void means that this function, and then I messed it up. Damn it. I've done so good for years. This method does not have a return value. We don't call the main method for its return value at all. In fact, it doesn't return any value, so we say it's a void method. And there's no return statements here. Main, your main method must be called main. This is how Java knows, actually, it's because it's public, static, void, it's called main, and it takes a string array as a parameter. All of those things have to be exact, or else Java won't treat this as a main method, and it won't start your program by calling that method. So it needs to be named exactly main. If you have a capital M here, it's not going to be treated as a main method because it's not. It needs to be all lowercase main. And then string array, this is our syntax for an array of strings. This syntax we're going to talk about a lot in the next example, very shortly here. But this method takes an array of strings as a parameter. And then the only thing that can change is this args. This is a variable name, so you're welcome to call it whatever you want. But just by convention and standards, we usually call it args. It's the command line arguments. This string array called args, we actually won't do anything with this in 116, but it will become important in future courses and your future career. But we won't do anything with it in 116. That's if you want to call your methods via the command line. That'll be much more important. Yeah, the main in Java will always be void. So it'll always be public, static, void, main, string array. All that has to be exact, or else it's not a main method. And the one thing that I skipped over, public. This is called an access modifier. For now, for this week, these first two lectures, everything is going to be public. What public means is that we can access this code from anywhere. So from any other class, from any other package, everybody has access to this code. and can call this method. You wouldn't really call a main method from outside this class, but you could because it's public, so you have access to it. We'll see private starting next week, which means nobody can access it except from within that class itself. For now, everything's going to be public and static. Everything can be accessed from anywhere without having to create objects. So yeah, public, static, void, main, string array, that's your method. The only thing that can change is args, but it's usually good practice not to. And yeah, this is why we don't do Java in 1.15, because that's literally day one. Day one of 1.15 or day one of AP is all of that. And then you go, holy crap, programming is way complicated. Well, Java is, but it's just a lot of overhead. And throughout the semester, all these keywords are going to, not main, I didn't mean to point to main. All these keywords will make a lot more sense as we get more practice and see other examples. But for now, we have a main method. We can call that method and finally write some code that does something. So when we finally get to write code that does something, we're going to print to the screen. And of course, it's Java, so just printing to the screen has to be more complex than it needs to be. We can't just do print hello Java. We have to do system with a capital S dot out with a lowercase o dot print line with a lowercase p and a lowercase l, and then the string that you want to print. So it has to be way more complicated than it needs to be, but there are reasons for all this that we won't get into. But system.out.println, and then the string you want to print. Or in IntelliJ, IntelliJ has a few shortcuts for you. You can do sout, and it'll type out system.out.println. And in fact, you can also type out main. I think I missed that bullet point. If you just type main in IntelliJ, it'll fill in all the template for you. So I would type main and sout, and then just type the string that I want to create in IntelliJ. So it has a few shortcuts that can help us out. And every statement in Java ends in a semicolon. So semicolons at the end of our statements. We got IDEs these days, so it really doesn't, I should highlight this one too. We have IDEs these days, so it'll just give you the error message. If you miss a semicolon, then you just go fix it. Back in my day, I always feel old when I say this shit, but we used to have to find these semicolons, these missing semicolons. You would run your program, and you'd get big error messages. Error messages from compilers used to really suck too. It would just be this big pile of errors that had made no sense at all. And it's because you missed the semicolon somewhere 5 miles away from where the error message is saying it is. Where the error message is saying the error is. Alright, and let's do a quick demo of that. Like if I delete all this code. So I'm in package week 1, so source week 1, hello world, so I have the class hello world. And I can use the shortcuts. If I just type main, let my autocomplete come up, and then sout. Let's see if I can type. Hello Java. And then in IntelliJ, I can click on one of these go buttons to run it, or I can right click and run it here, which is the one I'm going to choose. And then it'll take a while. You'll see a progress bar, a whole bunch of extra crap here, and then actually printing hello Java to the screen. So we just ran our first Java program. I need these extra things open. I need a slicker way to transfer between them. Okay, moving on. We're going to go through a lot of 1.15 today. So let's move on to variables and methods. And there's one huge topic that we're going to talk about as we're going through this, especially if you did do 1.15 here and you haven't done Java before, is strong typing. We need to specify our types throughout our program. We saw that in the Hello World example, but it wasn't super relevant. But here, this example is made to be relevant. Oh, and I saw one typo on my slides. This isn't going to take an int, so these are going to disappear on the next slide. and I neglected to update the slide. But that's a minor thing. I think it'll be fine. So let's take a look through this and, of course, focus on the Java-specific details. And there goes my parameter. All right. Java is strongly typed. This is the big thing we need to focus on. This will be the big adjustment if you haven't worked in any strongly typed language before. This is our really big deal with starting out with Java. So Java is strongly typed. That means whenever you create or declare a variable, you must specify the type of the variable, and that includes parameters of functions. You must specify the type of the variable, and then that variable can only ever store values of that type. So when I create the variable called num, I don't use any, like in JavaScript, we would use var. Well, don't use var these days, but you could use var, let, or const, or nothing, which has strange behavior. In Python, you just started using the variable, and it just knew that you wanted to declare it. But you wouldn't specify a type. In Java, you specify the type, and that's it. The type of the variable, and then the variable name, and then assign it a value, which is technically optional, but I'll always assign, I shouldn't say always because there's a few cases later, optionally assign a value to that variable as well. If you don't assign a value, you get a default value, which for double would be 0.0, but I'm getting a little off track here. So num, the variable num, can only ever store a double throughout its entire lifetime. It can only ever store a double and no other type of value. So it's initially 2.4, and if I tried to reassign num equals hello as a string, that would be an error. It would say, the compiler would run it and say expected double got found a string. I don't know what's going on here. The types don't match, and then everything would break. And I said the word compiler a few times. I should explain that just ever so briefly. I'll talk about it in a little bit more depth in a later lecture. But the compiler, so Java is a compiled language. When I ran that Hello World program, there's the progress bar on the bottom. That was the compiler converting our code into another language, which is actually Java bytecode. And then that other language is what's actually ran or interpreted. JavaScript and Python were interpreted languages, so the code itself was ran directly without compiling it into another language first. So in Java, what you'll get is compiler errors. That compiler will detect that type mismatch and give you an error before your program ever even runs. Whereas JavaScript and Python will give you runtime errors where your program runs, and then when it encounters an error, it'll crash. A lot of the errors you'll see coding in Java, if you see errors, maybe you're just crushing it. But if you see errors, they're more likely to be compiler errors, where your code never even got the chance to run because the compiler double-checked all of your work and said, oh, hey, something's not right here. And a type mismatch is one of the big ones that we'll see. So we declare a variable named num of type double and assign it the value 2.4. Now our first method call. So let's talk about the method declaration first. When we create a new method, and then we'll talk about calling it. Calling it's the same in pretty much any language, but let's talk about how to create a method. So there's a few big new things here. Public static we've seen before. This is the same as the main method. Public means that anybody can call this method. You don't need to be inside this class. If I had a class in a different package with a different name, a whole different part of my program, it would still be able to access this method because it's public. It's static, so that means that we don't have to create an object of this type to be able to call the method. We just call the method through the class. We could actually do variables functions dot multiply by 2. It's called through the class directly. And that gives us just an easy way to call our methods for these first, I say few weeks, again, made for a longer semester, but for the first 1 week we're going to see a lot of public static, so we just have access to everything and can call them simply. That we've seen before in the main method, but now the return type. With our main method, I said it has return type void. It means it doesn't return anything. So let's take a look at a method that does return something. This return type will be the type of the value that the method will return. And this is a guarantee. It will return a double. I say this method returns a double. It will. It has to return a double. No other choices. It's returning a double. This is a contract that we sign with Java. We say, see what I mean with the, I wasn't even looking at this bullet point. This is just how I explain this. What I'm talking about with the, should you be able to use your code from a previous semester? Well, it's just going to be the same. You're creating the same person's creating the same thing. That's just how I explain it. This is a contract with Java. I'm saying this method will return a double, and Java will hold me to that. Java will say, hey, if I write this code in any way that doesn't return a double, Java's going to come in and say, I ain't touching your code. Your code doesn't do what it's supposed to do. If you break the contract and say this returns a double, but I don't return a double, Java's not going to compile my code, and it's going to cross its arms and say, no, you said double, I need a double. So this is a contract, a guarantee with Java that this method will return a double, and the compiler will hold you to that. Then the name of the method, I think I can skip that part. That's the same in any language, no matter what language you've done CS1 in. I'm just naming my method. Should start with a lowercase letter and then camel case after that, for what it's worth. It drives me, I don't harp on naming conventions, but it does drive me nuts when students have like methods that start with uppercase letters. Though it does help in cheating detection if two students start their same crappy methods with uppercase letters. It's more evidence that they cheated, because why are they doing that? I never showed them that. Yep, so every method has to have a return type. You don't actually have to have public or static here. You could get away without those. It would be, why'd I back myself in this corner? It would be package default would be the access modifier, and it would not be static. But you have to have a return type. If the method shouldn't return anything, like our main method and like the next method we're going to talk about, then you would make the return type void to say, hey Java, I'm not going to return anything, so don't hold me to any contract. So that's what we'll use void for. But we do need some data type, even if that type is void, which means nothing, the lack of a type. So our parameters, our variables, they got to have types. So we have to specify the type of each of our parameters. We just have one parameter here, but if we had a parameter list, then each of those parameters need a type. And then when we call the method, we have to give it a value of that type. This is a little bit laxed in some cases. If we call multiply by 2 with an int, for example, I haven't even introduced those types yet. But int is another numerical type, but it can't have a decimal point. Like this 2 would be an int because it has no decimal. Java would automatically convert that int to a double for us. So there's a little bit of forgiveness, but not much. If I call it with a string, it's going to break. If I call it with a boolean, it's going to break. So it needs to be a type that's going to be suitable as a double. And then I'm just doing some silly stuff here. This method is pointless. You wouldn't ever actually write a method like this. I'm just using it for an example, of course. But I'm creating another variable named x of type double. I'm assigning it the value of input times 2, and then returning x. Once we hit a return, and indentation does not matter. Once we hit a return statement, the method ends and returns whatever value you give it in the return statement. So this is going to take 2.4, multiply it by 2, get 4.8, and return the value 4.8. So this method call, this expression is going to resolve to 4.8, and it's going to be used in this statement, num equals 4.8. Statement ends in a semicolon. But when we return, the method ends, and that return value has to match our return type. and we print that to the screen. New num, the concatenation operator, we're calling this with a string on the left-hand side, so this will not be addition, it'll be concatenation. And there's another case where Java helps us out, and it will automatically convert num to a string for us, and then concatenate it to the other string. It's something we sometimes have to be careful about, but it shouldn't come up in 116 unless you're doing something really wonky in your code. That you could get that plus to be addition instead of string concatenation. So something to be a little careful about, but probably wouldn't come up. So even if it did, it'd be printing to the screen, and there's nowhere where I'm grading what you're printing to the screen. So you'd probably be good with that one. Alright, and then one more method. We have another method call here, this y method. Why? Because why would this method ever exist? I would just print to the screen down here. Same with this, I would just say num equals num times 2, of course. But just to show two examples of methods, one that returns void and one that returns a type. So the brand new thing here is, of course, the strong typing. These doubles, these voids, double. So this method has return type void, which means I don't have to return anything. And I have no return statement, doesn't return anything. These methods are called for what's called their side effects, where they have some effect on the state of the program that other than their return value. Since it doesn't return anything, I can't be calling this method for its return value. I'm not calling it to like do some math for me or anything. I'm calling it for its side effects, and in this case the side effect is printing to the screen, which is the only side effects we'll really see at this point in the semester until we talk about objects, and then side effects will be a big conversation. But we will see later in the semester a lot of methods that return void that do have side effects that we do care about, that won't be printing to the screen. And then once we hit the end of the main method, the main we'll introduce pretty soon, the main stack frame will end, and that will end the entire program. So once we reach the end of the main method, program's over, everything shuts down, memory's freed up, and Java says, all right, we're done, and we get out of there. All right, any questions on this? Well, I'm not ignoring y'all, but I'm realizing that I have no way to really look at the time, so I'm going to set an alarm for the end of lecture. Make sure I don't go over, and make sure I get the right time, not 2:40, 1:40. 1:40 p.m. 1 hour and 16 minutes from now. Oh man, we got a lot of content to get through in an hour 16. Alright, no questions? Let's go. Types. Alright, so I was careful in the last example to only use double as a type. Oh, I forgot there's a delay. I should probably wait longer than that for questions. What will it look like if there's no static in the method? If there's no static in the method, this, like if we just straight up delete static right here, this code won't run at all. We would have to create an instance of the class. We would have to say new variables functions, and then call the method through that instance of the class. But we can't just straight up delete static. We would have to change the code pretty significantly, which is something we'll do next Tuesday. We'll see all about how that works. But for now, we'll just leave static in there and not create objects of our classes. Okay, I'll still watch for questions. If you have questions, I think the delay feels like it's like 10 or 15 seconds. I'm not going to wait half a minute every time. But if you have questions, I'm trying to keep an eye on chat. It's going slow enough here that that's easy enough to watch. So, yeah, just ask questions. Feel free to interrupt whenever you want. Alright. Java is strongly typed. That's the big thing. And I was careful in the last, I just said this, but I was careful in the last example to only use doubles, to just introduce one type to start. But now let's talk about a few other types that we'll use this semester. And these are the four big ones, I'd say, that we're going to start with. For what it's worth, if you're wondering why I'm not going to mention it, string array, this array syntax, we're not going to use that at all. I think we completely avoid that. I think we've successfully avoided it everywhere except the main method, but we never do anything with args, so we get away with it. But these are the 4 big ones that we're going to start with. So double, this is a numerical value that can have a decimal portion. So if you ever have some number point something, it's got to be a double. I shouldn't say gotta be. There's other types that we're not going to talk about. Float is the one that comes to mind here, which is like a double but has less precision. So, but double is just the one that we're going to use. I'll use double instead of floats wherever. For what it's worth, I use int instead of long or short. Just because. No big reason. I just had to pick one. Because I don't want to, flood you all with tons of different types. We'll do plenty of that later in the semester. Don't worry. So double can have a floating point value, and doubles are represented in 64 bits. Since I did mention them, floats are the same thing except they're represented in 32 bits. So 64 bits is, as it turns out, less than infinity. So the computer does have to do some truncation here and can't represent numbers exactly, depending on what the number is. There are certain numbers that would require infinite repeating decimals, and those values can't be represented exactly in less than infinite bits of information. So there is some truncation. So 2.4 might not exactly be the value 2.4 when it's represented in the machine, and that will be very important starting on Thursday in 2 days. String, the next type. We see these in every programming language. Technically, it's a sequence of characters, which is the data type char, and we'll see a little bit of char at some point, but not too often, not too much. Only when we're iterating through the characters of a string. It's the only point where we'll expect you to work with char. And note the capital S and the fact that IntelliJ has this highlighted in a different color than our other types. That would be fairly consequential as we go through the semester. But so this is a capital S. That means that this is a class type. There is an actual class called string where we're getting all the code for the string class. Double, int, and boolean with lowercase values. These are what we call primitive types, which do not have any class associated with them. They are strictly the value that we give them, and that's all it is. It's not an object of that type. And for what it's worth, when we do get to memory diagrams, we're going to treat strings as primitives. I know that'll bug some of you. It bugs me, to be honest. But it makes things a lot simpler when we do our memory diagrams. Int is a whole number value, meaning that it cannot have a decimal portion. Can be, why do I have this can be negative bullet point here? It can be negative, but doubles can also be negative. Having this bullet point makes it almost imply that doubles can't be negative. Doubles can, I didn't put it here. Doubles can be negative also. That's not unique to ints, but can be negative. And the big thing I want to say about this, I mean, they're numbers, they're integer whole number values. The one big thing that I want to say about this is that dividing two integers together is going to result in an int. So 6, I have no decimal portion here, so Java is going to treat this as an int literal. 4 with no decimal point, that'll be treated as a int literal. So if I divide two ints by each other, I'm going to get integer division. The result will be an integer, even if there was supposed to be a decimal portion. The entire decimal portion will be removed. It'll effectively take the floor of the quotient. Oh man, is that the right word? I think it is. It'll completely ignore the remainder and just give you the quotient. So 6 over 4, which we'd expect to be 1.5, is going to give us 1. And since it is the floor, even if we have like 99 divided by 100, it's still going to be 0. So this is one thing to watch out for, is integer division. If we have two ints, dividing them will result in an int with this truncation. To avoid that, if at least one of the values is a double, then you won't get this truncation. So if I had 6 divided by 4.0 and actually typed the 0.0, then it would no longer be integer division. I would get the floating point value or the double 1.5, And then in this case, I would get an error because this is of type int, and this would be resolved to a double, so I wouldn't be able to assign it anyway. Since this will be integer division, this will result in 1 as an int, and then I can safely assign it to my int value. Boolean, I don't really have anything to say. It's true or false. You've seen this no matter what language you're coming from. But for what it's worth, lowercase t, lowercase f on your Boolean literals. All right, and let's do our very first memory diagram. So this will be a big point, and I am going to switch. I did do that for the memory diagram, right? Yeah. So I am going to switch back to having an int that we take for this function y, just to get another parameter in there. And we're going to do our first memory diagram. So this is, roughly, I don't know if you want to assign percentages, roughly half the course. Maybe 40%. You'll spend more time on your programming assignments than on your quizzes. I mean, unless you study the way you should, I guess. Most students spend a lot more time on their tasks, their programming tasks, than their quizzes, because I suspect that they don't study, and then they tend to fail a lot of quizzes and need those second chances, those second and third chances. You're all going to study for the quizzes, though, right? And knock them out the first time. I hope, anyway. I'd love to see it, to be honest. So when this program runs, what we want to do is trace through everything that's going to happen in memory when this code executes. And the big thing, at least for this example, is what variables and values are going to be stored and what stack frames are going to be created when we have method calls. So a bunch of new vocab there. Let's go through it and talk about what this is. So memory diagrams, our very first memory diagram. So we always start our program at the main method. So that's where our execution is going to start, and I always have these green arrows to show where where we're currently executing is where the green arrow is. And then we're going to. Ooh, that's a good question. Will the quizzes be open? No. I mean, I guess they have to be. Like, how the hell am I going to police that? So I'm not going to do... I think lockdown browsers are an invasion of privacy. I'm not doing any of that shit. I think I kind of just have to say yeah, because if I say no, some of you will anyway. And I wouldn't have a way to police that. So yeah, I guess they have to be open no's. Not thrilled about that, but yeah. That's a good point. I'm glad you asked that. I ain't even thought about that. Yeah, open no quizzes. What other option do I have? I just have to make sure the quizzes aren't too similar to the lecture examples. I guess is the only thing I can do. Make sure that they look sufficiently different to make sure you understand the concepts and aren't just copying over from the lecture example. That means grades should go up, right? So the way the memory diagrams will work, I'll show them digitally in lecture because I don't really have another option. I don't even have the document viewer. Like sometimes we'll do them by hand in lecture. I'll do a few of those usually each semester. I don't really have that option. I don't really have that set up here. I could try, but I don't know if that would pay off. I don't know if that would be worth it. Oh, I'm covering up the slide. I'm covering up my bullet points here. I just realized. I guess I can, oops. I guess I can move me over here. Hopefully cover up less important words. So you'll write them, pen and paper. If you want to do them, I guess I wouldn't stop you from doing them digitally, if you have a good way of doing that. But my intent is that you'll write them pen and paper, and then take a picture with your phone, and then submit that picture to Autolab. That's my intended strategy. But as long as you can submit an electronic copy of your quiz to Autolab, within the time limit. I guess I don't really care how you generated it. We're working on a system, and then we can use that tool during lecture and create them using the same tool. We're just not there yet. It's not quite ready. All right. So we want to track everything that happens in memory when this executes. So here's what our memory diagram is going to look like. We're going to have the stack. This is where the computer stores all of your variables and keeps track of the scope of those variables, where scope is which variables can and cannot be accessed at any given time. Which stack frames are going to be a big part of that, and also code blocks. So those are the keywords to look out for. You shouldn't know what those mean yet, but we'll cover them. And then there's also something called the heap, but that's a conversation for next week. But I'm still going to put it in our memory diagram because it is a fundamental part of the memory diagram, even though it's going to be empty this week. And we're going to have one last section, in out. This is our input and output. This is where anything that's printed to the screen is going to go. So you can put this wherever you have room. We don't have a specific standard, like you must put your in out right here or right there. You put it wherever you're going to have room. And I know the heap's going to be empty, so I'm going to put it over in the heap because the stack's going to get filled up in this diagram. All right, and then we're ready to start tracing through this code. So the very first thing that happens, we start with the main method, and then we print icon print to the screen. So this is something that's printed to the screen. So in our in out, we're going to print whatever that is to the screen. So we're tracking, the whole goal here is to track everything that's happening in the computer as this program runs. And we also want to keep track of what's printed to the screen that you'll see when the program runs. So this is the one part that you would see if you ran this program, and the rest is how is the computer getting this stuff done. Then our first variable declaration. So we're creating an int named num with the value 4, and we're going to add that to our stack. Our stack is split into name and value, and this is where all our variables are going to go. We create a variable named num, so name is num, and the value is going to be whatever value we assigned to that variable. So what value is this variable currently holding? That's going to be the value right next to it on the stack. And notice that we don't put the type. We're not going to put our variable types in our memory diagrams. The type is implied. Well, one, I have 4 and not 4.0, so it's kind of implied that this is an int. But if you're at the point where you're writing memory diagrams, we assume that you know what types everything is. We don't need that cluttering up the memory diagram. There are a few things that we do that we just reduce the clutter in these diagrams because they get big. There's a lot that goes on in these things as we go through the semester. So anything we can do to trim them down a little bit, we will. Alright, and then we're going to declare another variable num2. This is a double with the value 2.4, so num2 goes on the stack as the name, and the value 2.4 implied that it's a double because we have this decimal portion, 2.4. Create a string variable, str1, and assign it the value a string, and that goes right next to that variable name. The value is a string. This is where, do I have a slide on this? No. But this is where I want to give my disclaimer. For those of you who know, yes, we are putting strings on the stack. Strings, in fact, in reality, do not go on the stack. They go on the heap, and then str1 will store a reference to that string on the heap. And then every time the value of the string changes, it would create a new object on the heap and then update the reference to refer to the new object. Because strings can't actually change, they're immutable, they can't actually change. But conveniently enough, strings behave exactly the same way as our primitive types like int and double. They behave the same exact way as ints and doubles to us. So we are going to simplify. This is one thing that we just say, you know what, let's simplify this a little bit. And we are going to pretend that strings go on the stack because they behave like they go on the stack. It is a little more complicated than that, as I just explained. But I'm going to save that for a future instructor in 220 is probably where that'll come up. I'll let Ethan or whoever you take 220 with, I'll let them straighten you out, and they can say, yeah, Jesse's an idiot for putting strings on the stack. I don't know why the hell he does that. You can make fun of me, and then he'll show you the way that it actually works, how immutable references work. But for 116, let's just simplify it. Keep it as simple as we can, because honestly, there's enough stuff to learn. There's a lot to learn in 116. Anything we can do to cut out one topic, we're going to do that. All right, and then we have num3. We're declaring a new variable. And by the way, when we're declaring a variable, a little tip or cheat code or whatever, whenever you see the type and a variable name, that means we're declaring a new variable. So a new variable is coming into existence. That means it's going to be added to the stack. If you don't see the type, like right here, we just have num2 equals something. That means we're reassigning the value stored in num2, and we're going to update its value. But whenever you see the type, that means a new variable is being declared and added to the stack. This is integer division, so don't forget about our integer division. Num3 is going to have the value 1 because the 1.5, the 0.5 part of that is truncated to make it an integer. And let's get a boolean on the stack too. Declare a variable named bool and assign it the value true. So the name of our variables and then the values of our variables. And then whenever we need to use a variable, we're going to look up the value of that variable. So we're going to print I am num3 and then the value of num3 to the screen. And here's where if you're reading through the code without doing a memory diagram, you'd be tempted to look over here, find num3, find the value it's assigned to, remember your integer division again, and then say, oh yeah, num3 has the value 1. When we're doing memory diagrams, we're not going to do that. We're going to be just like we are the computer. The computer isn't going to reread the code every time it needs a variable value. What it does is say, oh, I need something called num3. It's going to go to its stack. It's going to look at the stack, find a variable named num3, and then go to its value. And that's what that variable resolves to, is that value that's sitting next to that name on the stack. So it's just going to look at the stack. What's stored in memory at this given moment, that's the value that num3 resolves to. And then concatenate it and print it to the screen. Everyone good on that so far? We declared a few variables. We printed to the screen. Take a little breather because the next thing is going to be our first method call. If there are questions, I'll keep watching chat, but if it's getting too overwhelming, I don't know. So far, I don't think we declared some variables and print things to the screen. I don't think any of that's too complicated, but this next part might be just because there's a bunch of new stuff about to happen. So if it ever gets to be too much and you're getting overwhelmed, just ask some questions. That'll slow me down. All right, so we have this method called multiply by 2. Multiply by 2 takes a parameter and assigns it the value of the argument. And when a method is called, we create something called a stack frame. So we add a stack frame to the stack, and we represent this as a solid box when we add it to the stack. When we create a stack frame, we are creating a whole new section of the stack. It's sectioned off just for this method call. And from inside the method call, from inside the stack frame, you can only access variables that are inside that stack frame. Once we go into this method call, we cannot access any of these 5 variables. Even though they're on the stack, we cannot cross this solid line and access them. We can only access variables that are inside the stack frame, which is really limiting. It's really limiting in what we can do inside a method call, and that's why we need our parameters. So the very first thing that goes inside a stack frame when it's created, once we hit this method call and create a stack frame, the very first thing we add to that stack frame, oh, I got ahead of my slide there. The very first thing that we add to that stack frame are any of the parameters. So we have the parameter, we're declaring a variable. Remember, whenever there's a type next to a variable name, that means we're declaring a new variable. This variable of type double named input is created every time we have a method call of multiply by 2. So we add input to the stack frame. Oh shit, I forgot about that part. I'll circle back to that. I want to finish my point here. We'll add input to the stack frame and assign it the value of whatever we gave it here. Now, we gave it num2, the expression. That was inside the main method. So there's technically a stack frame for the main method too. In our diagrams, we don't draw it. But inside the main stack frame, we have num2, which we have access to right here, 2.4. So this resolves to 2.4, and we send that 2.4 into the stack frame assigned to the value input. So parameters assigned to the values of the arguments, which is like this hidden assignment that happens when you call a method. But in our memory diagrams, it gets a little bit more explicit because we put that value right in the stack frame. So if we change the variable, do you write it again on the stack or just change the previous entry? We're going to cross out the value and write in the new value. And num2. So num2 is going to be reassigned. We'll see it right here. We're going to cross out 2.4 and replace it with our 4.8. Spoilers, by the way. So when we create a stack frame, I went a little bit out of order here. So let me go back to this slide. When we create a stack frame, we have to add 2 things here. Well, the stack frame itself, I guess, so 3 things. The name of the method that's being called off to the side of the stack frame. So we know that this is a call of multiply by 2. And then a return arrow showing where the return value is going to be assigned. So we have num2 equals multiply by 2. So we have a stack frame for multiply by 2. And the return value is going to be assigned to the variable num2. So we're going to draw our arrow to num2 to show that when this does return, it's going to dump its value right here. If this were a new variable being declared, if this were like int num4, we would write num4 with no value and then the stack frame below it and then the return arrow going to num4. Yeah, thank you, Unknown Mischief. Alright, so we got our stack frame. We have the name of the method being called. We have our return arrow showing where the return value is going to go. And our return value has to match the type of the variable. Num2 happens to be a double, and we're returning a double. So we got that one right. We got that one good. And we're going to return x, which is a double. So all our types are matching. We're happy about that. We declared the parameter, put that on the stack, and assigned it the value of the argument, which was num2, which I'm not going to look at my code to figure out what num2 is. I'm going to look at my memory diagram. Num2 has the value 2.4, so input equals 2.4. Yeah, it's effectively the floor of the division. Just divide and then round down. It's a good way of putting it. And notice in my memory diagram, I'll have my arrow. The green arrow is always what's currently executing. We're executed kind of this hidden, I always call it the hidden line of code in 115, where we have double input equals num2. It's a line that's broken, a statement that's broken across 2 lines. I call it the hidden line usually. That's what we're executing right now. And I'm going to put this gray arrow to show where we are in the other stack frame. So in the main stack frame, this is a method call, so technically it does have a stack frame, even though we don't draw it on the stack. It's everything that's not in a stack frame visually is in the main stack frame. So this is where execution is going to return when this method call ends. We're going to pick up right at this arrow where this arrow left off. The arrows you wouldn't have to do in your memory diagrams. That's just something I do for the slides. But this whole part, this is what you'll submit on your quizzes. Once it's done, of course. You'll submit your memory diagram for credit. Alright, so we're inside this method call now, which is executing in this stack frame. So we don't have access to any of these variables. If we said double x equals num2 times 2, we would get an error. It would say variable num2 can't be found, because it cannot cross this line and access any of these variables outside of the stack frame. And there's a very important reason, well, at least one important reason, there are several, but there's one very important reason of why that is. It's so when you're writing a method, you don't have to worry about name conflicts with your parameters or your local variables. So input and x, I just pick whatever I want for those, and if I also chose input and x down here in the main stack frame, since they're in different stack frames, we can reuse the same variable names. That's perfectly fine because you can't access anything outside the stack frame anyway. So if I'm writing a method that's public and static, meaning anybody can access this method from anywhere, I don't have to worry about what they name their variables if they're going to call this code. Like if you're calling Java's internal math.pow method, you don't have to worry about what they name the variables inside that method either, because it's going to be executed in a different stack frame. You don't have to avoid any of the variable names that they've used. That would be a huge pain. It would make programming very, very difficult. We'd probably create all our variable names with like some unique identifier, like Jesse underscore, and then the variable name. We don't play those. We don't do it like that. We don't play those games. Oh, by the way, I forgot to introduce myself. I usually forget, but you can just call me Jesse. I go by Jesse. If you want to call me Dr. Hartloff or Professor, you're comfortable with more formality, that's fine too. I'm fine with that. But just Jesse is fine. We can keep it casual. We don't have to get titles and stuff involved. So that's my whole introduction. Done. If you want to know more, you can ask, but we can just focus on computer science too. Alright, so then whenever a variable is declared inside a method call, that variable goes inside the stack frame for that method call. So this variable x is being declared inside the stack frame because it's inside the method call. It's inside the braces of that method. Declare x, it's input times 2. Even if we had an input out here, it wouldn't matter because we can't access that value, that variable. So input, we only look inside the stack frame for a variable named input. When we find one, it has the value 2.4. So this is 2.4 times 2, which is 4.8. Assign 4.8 to the value, to the variable x inside the stack frame. And then we return x. So x is going to be our return value. We resolve the expression x to 4.8. And then 4.8 is what we're going to return from this method call. And we're going to assign num2 to 4.8. So we'll cross out the old value that was stored in num. No matter what it is, it's being overwritten. And then write in the new value 4.8 for num2. And then when a stack frame ends, once a stack frame returns, we cross it out. So in your memory diagram, you cross out any stack frame that ends. When a stack frame returns, it is actually erased from memory. It's like it never even happened. Once we return and get back to our main stack frame here, it's like that stack frame never even existed. In our memory diagrams, we're not going to actually physically erase anything because the whole purpose is for you to give us like a whole transcript of everything that happened throughout the method call, but we will cross it out to denote that this is no longer in memory at this point in time in the execution. So cross out the stack frame. Input and X do not exist anymore after this method call ends. We return control back to our main program after that method call, after that stack frame ends, and then continue with our execution. So a stack frame is created every single time we have a method call, and that stack frame is destroyed whenever we hit the end of that method call. So method call and stack frame, they go hand in hand. Method calls have stack frames that they execute inside of, and then once that method returns, that stack frame is destroyed. It's removed from memory, which we denote by crossing it out. That's stack frames. That's probably, well, that and strong typing, the first two big topics that we're learning, and memory diagrams in general. And then new num2, and then the value num2. Num2 now has the value 4.8, so new num2, 4.8. Print to the screen. And we have another method call. This why does this method even exist? It's only for educational purposes. Y of 2, and why does it take an int? Why does it take a parameter when it doesn't use it? Everything about this method is just here for educational purposes. So we have another method call. Oh, I forgot to mention something. If a method call, kind of a caveat to just the way we do memory diagrams, whenever we have a method call, every single method call ever creates a stack frame. But if that method call is a call that we don't have access to the code, like println, system.out.println, I don't see the code for that method anywhere. So we're not going to put that stack frame in our memory diagram. So in general, whenever we have a method call that's internal to Java, we're not going to trace that in our memory diagram. You only have to trace the code that we give you on the quiz. Because you're not expected to know, like println might have some local variables. By the way, X, like a variable declared inside of a stack frame is called a local variable. Println might have some local variables. We have no way of knowing without actually looking at the code. So I don't know what I would even expect you to put in the memory diagram. You also don't have access to the name of the parameter that's going to get this value. I just don't know what I would even expect you to do there. So we just don't put those stack frames in our memory diagrams. But if you can see the code, if we give you the code on the quiz, then you better be tracing it. So why we have access to the code, so we're going to trace this. Create a stack frame for the method call. Put the name of the method next to it. And then the return arrow where it's going to return. But this method has a return type of void. So if it returns void, it doesn't return anything, there's no arrow to draw because it's not returning to anywhere. The only thing that might make sense in this case is drawing an arrow to in, out, but that doesn't really make sense to me. So we just don't draw any arrow for a void method call. That method call has the side effect of printing to the screen. It returns, because we hit the end of the method. We either hit a return statement or the end of the method. That's going to end the method, end the method call, and destroy the stack frame. So once that method is over, cross it out. Don't forget to cross out your stack frames. Then we hit the end of the main method. It has return type void, so we don't expect to hit a return statement. We're going to hit the closing brace. And once we hit that closing brace of the main method, the main stack frame ends and the entire program ends. Once we hit the end of the main method, that's the end of the program. Everything is removed from memory. We don't cross out the main stack frame. We just leave it at that. And then what we're left with is the complete history of everything that happened as this code executed. Even if we didn't have access to the code, we can pretty well see what happened here. We declared a variable num with the value 4, num2 with 2.4, string num3, boolean, variable named bool of true. Created a stack frame that returned 4.8 into num by calling a method multiply by 2. then called a method named y, which did something. We don't have a 100% transcript of everything that happened, like when things printed to the screen, but we have a pretty good idea of what happened in this program. And specifically, if we do have access to the code, we can tell if you have the right stuff there. That's Vincent. That's going to be Jackie's goal. That's been Jackie's task to edit. He did a really good job on the first one. He's working on the second one. Like how he spliced in some memes in there. But yeah, he'll get it together. He might still be in here. If he's in here, yell at him. Tell him to get it going. Which brings us to the end of this one. So I'll take how much time we got? 40 minutes? I can't sit too long, but if anybody has questions about this memory diagram, now's your chance, because I gotta switch to the other slide deck. So that's 2 lectures. That would be Monday and Wednesday of the first week. Excuse me, if this were a fall or spring semester. Then we gotta go on to Friday. This is a lot of content really fast. I hope y'all are ready for this. I hope everyone who's not here is going to watch this lecture today and not wait till Friday or something. In the quiz, do you have to write I return nothing for it? If this were the code we're given, the reason why this was printed to the screen is because it's literally printed to the screen right here. But if a method call just doesn't return anything and doesn't print to the screen, you wouldn't write that I return nothing. But since this printed the string literal I return nothing, that's the only reason this is here. I won't have a method that does that on the quiz. It'll print like, I'm having fun taking this quiz, or something silly like that, probably. The quiz will be sections of code, and we'll have to make memory diagrams. Yes. So what the quizzes will be, so each quiz is effectively 2 quizzes. So you have at least 2 programs like this. Like for the quiz, I have to switch slides anyway, so I can go to the website here. So the first quiz is going to be June 13th, in 2 weeks from today. That'll be your first quiz, and it'll be Classes 1 and Data Structures 1. So we're going to be quizzing you on classes and objects, creating classes and creating objects of those types with the keyword new. That'll be heap stuff and all that. And Data Structures 1, which is linked lists. So you'll get at least 1 program with each concept, and probably just 1. I mean, you only have an hour, so it's only going to be half an hour per memory diagram. I think I can only fit 2 diagrams, but 2 decently sized diagrams for these. And then we'll grade each one separately, so you can pass classes 1 but not Data Structures 1, or vice versa, or pass them both. Or hopefully not, but you could fail them both. But please prepare and pass them both. So you'll get 2 pieces of code. Oh, to more answer your question. So you get 2 pieces of code. One reflecting classes, one reflecting linked lists. And then you'll trace through both of them. So you create 2 memory diagrams, and we'll grade those 2 memory diagrams on that pass-fail basis. Will we have to cross off stack frames like you did once we're done with those functions? Yes. Are the quizzes just stack trace or multiple choice 2? Just stack traces. Just the traces. I don't think, even in the spring and fall, I don't think we're going to do multiple choice questions again. It didn't work out the way we wanted it to. With the multiple choice, most students did the entire trace anyway and then chose the one that matches that trace. So at that point, why not just make it tracing questions? Because there were cases where students did the entire trace and then still chose the wrong answer, but based on the trace that they drew, we could tell they knew what was going on. They understood the concept. It creates some really weird grading situations. If you understand the stuff, I want to give you credit. I don't want to take away credit on a technicality. So I got to open here and then double click. So it opens with that, just not from my browser. It's weird. Where's JDK and how do we correctly? You know what? I want to get to the I want to get to the IntelliJ tutorial, so let's do that now. So how do I want to do this? Let me start with. Oh, and once you please read and understand the syllabus and all that. But once you do, you can click this and it'll stay collapsed even when you refresh. And same with all the lectures. So as we go through the thing, you can have the most relevant content right up top. So let's go to the code. So let's clone this repo. I had mentioned the word clone before, so let's do that. So once we have IntelliJ installed, I think my mouse is on the wrong screen. We'll go to code and grab this link. Then I'm going to go to, oh my goodness, it's not saved in my doc. I do not want internet. Why do we even have Internet Explorer? I thought that was dead. We open up IntelliJ. It's going to open my last project, so it's already going to be there. But when you open IntelliJ, you'll get some splash screen. I don't even know how to get back to that splash screen on Windows, at least. On my Mac, I just close it, close the window, and it does it. But you'll want to find Git and clone, or Git from version control. It's depending on what version and everything. There's all kinds of different things. And I'm going to paste that link. Make sure you get the one that starts with HTTPS. I'm going to paste that link for the repo and then click clone. Actually, this is going to say you can't do that because I already cloned it. So I'm just going to put a 2 on the end of this directory name so it's cloned in a different directory, just for the sake of example. You won't get that error if it's the first time you're cloning it, though. And then I'll get all of the code for this repo. So I can look, I have all the code cloned, just that, that simple, kind of, except we have to set up our JDK. So before we do that, this uses, did I not update? I meant to update this to 20. It's fine either way, but we have this pom.xml, so there's actually a few external libraries that we're going to use. But with this pom.xml, it should set up all that for you so you don't have to mess with it. Pom is what's called Maven runs. And if you see this Maven on the sidebar, that means the Pom and Maven did its job. And IntelliJ is really good about running that automatically, so you don't have to worry about that side. I haven't had to debug that for a student in years because IntelliJ just does a good job with that. But to set up our JDK, you can get this banner and then just set it up that way. But just in case you close that or that doesn't show up, I'll show you the other way. Go to File and Project Structure. And it's going to open right up to this SDK, Software Development Kit. And we want to get a JDK, Java Development Kit, that's suitable for the project. And any late Java version is going to work fine. I meant to switch last semester, but 19 is fine too. Everything's going to work. You won't see all these options here, so we're going to go to Add SDK, Download JDK, and it's going to give us options. The default of 20 and Oracle Open JDK is fine. I'm going to download that, and I'm going to click OK. And then all my errors go away. All those red highlights were errors. And then I can run this. It's complaining that Open JDK 19 is missing. I swear I updated that. But then we get Hello Java. So that ran and everything's set up. Let me change this to 20. I think that's what the error is coming from. And I must have forgot to push. Update to Java 20. That I don't need, but the POM I need. Oh, maybe I didn't push. I don't know. I don't know what I did. Oh man, maybe this is why I didn't push. Okay, good. Now we're good. And if you ever want the latest code, sometimes I'll update examples and add new code. Click this blue arrow. I'll go don't show again. And then that'll grab the latest code. I'm up to date, so there's nothing to grab. And that's my Java tutorial, or IntelliJ tutorial. I know that goes fast, but you do have the video to go back to. And then for the programming tasks, you'll be given a GitHub link, and it's the same process here. You grab the link, clone the repo, and then you can start working on the code. And this has the starter code for you of some starter code that I give you to get started on the project. How can we activate IntelliJ? Go to program test 1. Go to this educational license, go to this link, and you should be able to get your academic license with your .edu. You'll fill this out, and with your .edu email address, it should be automatic. It usually happens in a minute or two. I don't provide practice quizzes aside from like the lectures. Like when, I think I do have another memory diagram here. Like the lecture is effectively a practice quiz. Like this, maybe this is a little too simple for a quiz, but like this is a sample quiz. I would give you code like this and you would generate the memory diagram. There's that and the memory diagram reference on the course website. This gives you some good examples of tracing through code. But I feel the slides with the step-by-step going through is more detailed than what I would give for a solution anyway, for a practice one. Okay. Ooh. My shoulder. I don't know what it is, but I forgot how my shoulder doesn't like reaching for this mouse all lecture when I'm streaming. I'll figure it out though. Alright, so let's do some more Java things. Conditionals, while loops, and for loops. And we don't have a ton of time for this one. I'll try to get through it. If we don't get through it, we'll wrap up on Thursday. Alright, conditionals. I don't have a whole lot to say about conditionals because the syntax is really similar to JavaScript and it's not too far off from Python, aside from the way we do code blocks, how Python really cares about indentation. But it's not really crazy. We have a conditional if some Boolean expression, then execute this. Else if, so if this is false, check this one. If that's false, check the next one. If they're all false, go to the else. And if any of these are true, don't check the rest of them because they're all else ifs. So I assume you're all good on that because it's 115 concept. Parentheses around each code block. And code block is going to be the new key term of this lecture, of this, I guess, portion of this lecture. But this would be a brand new lecture if it were 50-minute lectures. And then we're going to call the method. It should be pretty straightforward, even if you don't know how to read Java code yet, even if you're still struggling with the syntax a little bit. I would expect you to be able to figure out what this code does. You might not necessarily be at the spot where you could write this code. Well, maybe you could. I don't know. It's not too crazy, given your prior knowledge. But we're going to ask it, we're going to give this method an input of 98. We're going to do integer division. So tens would be 9. This would be true, and we'd return A and print A. Then we'd reassign result to letter of 75, which would be a C, print C, and then a 30 would be an F, print F. So that's what the code does, but we want to talk about how, why, what actually happens to get that to work. We're going to do that through a memory diagram, because why not? It's what you got to do on your quizzes. We need lots of examples of memory diagrams. Okay, start with the main method. That's where things always start. That's where we start. So we start with the main method. The first thing that happens, here's an example of declaring a variable and assigning it the return value of a method call all in one line. So to do that, we're going to put our variable on the stack first. Technically, I believe the computer will declare that variable after the method call. But for our memory diagrams, we're going to put it there first. So we have a place for our return arrow to point to. So we can say, hey, result, it's going to exist. Doesn't quite exist yet. It has no value. It hasn't been completely declared and defined yet. But letter is going to do things in this stack frame. It's going to return a value, and it's going to restore that value in result. So we put the variable first just so the return arrow has a place to go. I think I can move me back over here. Get myself a little smaller again. Actually, I just move myself over. I think that works. Yeah, I think that works. All right. So we're going to enter this stack frame. We're going to enter this method call. Method call and stack frame go hand in hand. So letter is the name of the method that's being called. We put that next to the stack frame. We draw a solid box for the stack frame. We assign the parameter the value of the argument, and then we start executing code inside the stack frame. So the first thing we do is declare a new variable, a local variable tens, which is going to be score over 10. So 98 divided by 10. The quotient is 9, the remainder is 8. We ignore the remainder and just assign 9 to the variable tens. And that's inside the stack frame. We're inside this call of letter. So that variable goes inside the stack frame. Then we hit our conditional. If tens greater than or equal to 9, which is true, then we're going to enter this code block. We execute this code block, which just returns A. So whenever we hit a return statement, we're done with that method. We're completely done with it, and we just get out of there. The stack frame ends, and we return A. So it's like a shortcut to say this method's over. This method would have been over anyway because we were done with this code block. Everything else is else. So we would have jumped to the end of the if statement and ended. But when we have a method in Java and we gave it a return type of string here, that means we are obligated to always return a string no matter what. Java will enforce this, and that includes in conditionals. So the way we're using these returns inside the conditional but never outside the conditional, that means that every one of these code blocks that could be executed must return a string. If even one of these did not return a string, Java would say, hey, this method doesn't always return a string. Y'all better fix that. In addition to that, if this last one was an else if tens less than 6, return F, that would also be an error because there's no guarantee, at least in Java's mind, which it doesn't even have. We have to be very particular with our computers. It would say, hey, this doesn't always return a string because what if all of the conditions are true? And we would say, hey, like there's no way. You can't be greater than, not be greater than equal to 9, not be less than 6, and not be one of these other, like it can't happen. But Java doesn't care. If there's not an else and you don't return after the conditional, you didn't return a string. So something to look out for. And the error message would be expected string found void. Type mismatch. All right, so cross out the stack frame and it returns A. Result is A. Print result, print A to the screen. All right, now we have another stack frame, and we're going to draw a return arrow into result. You notice my stack frame's a little bigger this time. There's a little bit more that we're going to do. When you're drawing your stack frames by hand, I recommend just not putting the bottom line on right away. Just draw the top, and then when you're done with the stack frame, then cap it off at the bottom. I have the advantage of, I actually make these slides backwards. I make my whole memory diagram and then start deleting things and making my slides backwards. So I have the advantage of foresight to knowing exactly how much room I'm going to need. So I get away with that, but on your memory diagrams, just leave yourself room for your stack frames. So letter score is going to be 75 in this case. Tens is going to be 75 over 10, which is 7. That remainder of 0.5, or the remainder of 5, or the decimal of 0.5, it's truncated, it's completely deleted, which means it will be effectively the floor of that value. It'll be the floor, so tens is just 7, which intuitively in this case, we're taking the tens digit. We took the 9, we took the 7. And then we're going to do our checks. If tens greater than or equal to 9, false. Else if tens greater than or equal to 8, false. Else if tens greater than or equal to 7, true. So we're going to enter this block. And here's where we want to talk about code blocks. And it's the whole reason why I created this variable and then returned it instead of just return C, which you would normally do here, is when we declare a variable inside a code block. This is treated a little bit differently than other local variables. So inside a code block, we're actually going to draw an additional block. We're going to denote the code block, which a code block is whenever we have a pair of parentheses that's not defining a method call, because that'll define a stack frame, or a class, because that'll defines the class. But any code block, any pair of parentheses inside a method, that's a code block. That's going to be a dashed line in our memory diagram, and we draw it as a dashed line because unlike stack frames, we actually can access variables that are outside of the code block. So we can still access score and tens when we're inside this code block. The big difference, which we won't get to see quite yet in this example because we're going to return and get out of here anyway, out of this method call, out of the stack frame entirely. But once a code block ends, any variables that were declared inside of that code block are destroyed. They're gone. Intuitively, you know this is the case from 115, but you might not have fully seen why. But if you have a variable that you declare inside an if statement, and then down here you try to say, you declare result here, and then down here after the conditional you try to say return result, it's going to say result not found. Can't resolve this variable to a value. And you're going to curse at the screen, you're going to say what the hell, Python or whatever language you're using. It's right there. The variable's right here. Why can't I return it right here? Well, it's because after the code block ends, that variable's destroyed because it was declared inside that code block. So that variable's gone and it doesn't exist anymore after the conditional. So here we're going to return. Here we're going to return result. I got ahead of my slide a little. And when when a code block ends, we cross it out just like we would a stack frame to denote that those variables are no longer on the stack. They are actually deleted from memory. And then that stack space would be reused by the next variable. Here we ended the whole stack frame though, so we cross out the whole stack frame and return C to result in the main stack frame, cross out the old value, write in the new value. Then we go back to our main stack frame and print result, which is currently storing the value C, print C to the screen. Then one last time, let's do it again. Tens is 3, false, 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 hit our else, return F, print to the screen. And notice that in the first and third call of letter, we didn't draw our dashed box for our code block. If no variables are declared inside a code block, that was the case for the first and third calls, if no variables are declared there, we don't even bother writing our dashed lines. You're welcome to still draw them if you want to in your memory diagrams, but they'll be empty. You'll just draw an empty dashed box. So if it's going to be an empty dashed box, we say, you know what, you can skip it. You don't have to write it. Why bother if it's just going to be empty? Cross out the stack frame, it returns F, print F to the screen. Program ends, we hit the end of the main method, program's over, nothing left to do. So code block is our new big thing here. And technically conditionals, but I hope none of you are struggling with conditionals still. If you are, I mean, I guess that's okay, but you really got to study 115 material if you're struggling with conditionals. And the difference between like consecutive ifs and else ifs, if you're struggling with things like that still, study up. You're already behind. Alright, oops. Hopefully that doesn't apply to anyone. I said that kind of dismissively. It's hopefully none of y'all actually fall into that category. Y'all gotta know conditionals by now. Alright, so loops. Let's take a look at a loop. The while loop, which is notoriously known as the missing loop in 115. So let's cover it real quick. They're not complicated, and I think they are adding it to 115 now. It's well, and then some conditional. And as long as that conditional is true, you keep looping. So as long as val is greater than 1, we're going to keep executing the loop, checking the conditional, executing the loop, checking the conditional, and we just keep going until this is false. So well, this is true, keep doing this thing. And that's it. It's mostly the same syntax as a conditional. Some Boolean expression and then a code block, except you keep executing. It's like an if that keeps checking. And notice with a while loop, actually with any loop, your loop might not execute at all. Just always something to keep in mind with your loops, especially when you're debugging. Your loop might never execute. If the condition is false on the first time that you reach the loop, it'll just completely skip it, and these 2 lines of code will never be executed, not even once. Same thing if you like loop over an empty data structure. For loop, this is similar to the syntax, almost identical to the syntax of a for loop in JavaScript if you're not using the for each loop. But JavaScript's being cut, and if you didn't take 115 here, then you didn't see that anyway. So let's cover this. So for, and then 3 statements separated by these 2 semicolons. We're going to have 3 statements. 1, the initialization statement. 2, the Boolean expression. This Boolean expression is the same as for the while loop. The while loop only had this statement. And then the increment statement. So what this is going to do is when we first reach this for loop, this initialization line statement is executed 1 single time. It's only ever executed exactly once. So we're creating a variable named x and assigning it the value 0. Then we're going to check the conditional, and as long as it's true, we're going to loop. We're going to run the body of the loop. And then whenever we get to the end of the body of the loop, we're going to execute this statement, the incrementer, which this x plus plus, if you've never seen this, it's the same as x equals x plus 1. It's just shorthand. Shorthand that we try to not show in 115, but in your second semester, you're ready for this, for shortcuts. A lot of students use it anyway in 115. They find out about it. Increment x, and then check the condition again. If it's true, loop again, and just keep going around the block. Execute this, check this, execute the body, execute this, check this, and just keep going around until the condition is false. So in general, here's our breakdown. Initialization, run once. Boolean expression to check if we're going to loop. And then each time we execute the loop body, execute the increment, and then go back to the Boolean expression. Those are 4 parts to a Java for loop. And let's do a memory diagram. You're going to be experts at memory diagrams after 1 lecture. And a few things now that we're seeing a few of these. The string array is technically on the stack, but since we're never going to use that in 116, why draw it? We're not going to bother. But it would be, and it would actually be a reference to an object on the heap. We're not going to mess with any of that. It actually be a reference to an array on the heap, which would have references to strings on the heap. We ain't gonna. We're just not gonna. So val, declare variable val. This should be feeling pretty familiar now, declaring our variables. Equals 10. And then val greater than 1. Now notice I can mix double and int here. Java will convert the int to a double 1.0 and then do the comparison. So this is a legal thing to do, converting ints to doubles is about one of the only things where you can violate types a little bit. There's a little bit of leeway in Java where we can do that. So well, I gotta figure out something of where to put me in these slides. These slides are made for the projector. So well, val is greater than 1. I have an idea. I think I might, whatever. It's not important. We gotta get through this memory diagram. So well, val greater than 1. So we're gonna check this Boolean expression. It's true, 10 is greater than 1. So we're going to execute the body of the loop. So we're gonna print 10 to the screen. We're gonna use this shorthand again, which we haven't seen yet. I guess we saw plus plus, but that's a special case. So this is read as val equals val divided by 2. So we're going to divide val by 2 and also reassign it, whatever the result of that is. And we're going to see these shorthands throughout the semester. Plus equals, minus equals, star equals. It means execute the operator on the right-hand side and then reassign the variable equal to that value. What would we write if we want to increment to be more than 1? Yeah, you'd write x. You wouldn't really be able to use the shorthand. You would use x equals x plus 2 or x plus equals 2. If you want this to increment twice, I would do x plus equals 2 would be the shorthand I would use. So this is going to divide val by 2. So we're going to cross out the old value, write in 5.0. And notice we are inside a code block. It's an empty code block because there's no variables declared inside of it. So we're not drawing the dashed line. There would be an empty dashed box right here. We're not drawing it, but we still are inside that code block. But we're able to access val from outside of the code block because you can access variables that are outside of the code block as long as you're still in the same stack frame. You cannot cross a stack frame, but you can cross a code block. Very important that we can do that. There's a difference between lectures and labs for the summer. There's no difference. It's all going to be lecture. I don't know why, but the schedule gives enough time. Like, it's the equivalent time that I would have in the first 12 weeks of the semester with just lectures. So we actually lose quite a bit of contact time because we lose that. We really do lose those labs. I don't know how they would expect me to cover everything without labs. So we have to jam some quizzes into lecture time and use all the time for lecturing. I keep thinking I missed something with that there must be a bunch of time somewhere else, but I don't think there is. It's just an abbreviated semester. All right, so we get to the end of the loop, so we're going to check the condition again. Val greater than 1, it's true. And I won't bore you with the details. We're going to keep going through this loop. Print, divide by 2, print, divide by 2. At this point, 1.25, the condition's still true. We're going to print, divide by 2. And now when we check the condition, 0.625 greater than 1 is finally false. So now we're not going to execute the loop again. But notice that val did get to a value that made this condition false. It didn't stop at 1.25. It actually was updated to 0.625, and then we break out of that loop. So at this point, val, since it was declared outside the loop, does still exist and will have the first value that made this condition false, which is 0.625. All right, now the next loop, we do create the code block because we're going to create a variable inside of this, namely the initialization variable. So whatever you have for this statement, for the initialization statement that's executed one time when we first get to the loop, this is executed inside the loop code block. Even though it's outside of the parentheses, technically it's outside of that code block, it still is declared inside that code block in terms of memory. And when we hit the end of this loop, x will not exist in memory anymore. So we initialize x to 0. We check the condition. 0 less than 5 is true. So we're going to execute the loop and just print out the value of x, which is 0. Then increment x. So we're going to update x, the x's value to 1. We're going to check the condition. It's true. and I'm not going to belabor this point. You get the idea. But x will reach 5. This is the point that I want to make. X will reach 5 after we increment and print all these things to the screen. And then check the condition again. 5 less than 5 is false, so the loop is over at that point. The body is only executed for x 0 through 4, but x does reach the value 5, but we never print the value 5. So keeping track of these kind of subtleties of how code is executed is going to be important this semester, paying attention to exactly what is going on in the order of things and how these things execute. We increment and then check the conditional, so we actually get to 5. That makes the condition false, and then we break out of the loop with x equals to 5. And when we break out of the loop, since x was declared as part of the loop, this stack frame, or this code block, ends once we hit the closing brace for it. It's removed from memory. Any variables declared inside that code block are removed from memory. So after this closing brace, we no longer have access to x. If we wanted to print x to the screen right now, right here, we couldn't do it. There'd be an error. X can't be found. Doesn't exist anymore. And that's why you can't use those variables declared inside a code block after the code block ends. They are actually deleted from memory. It's like they never existed. After this closing brace, the computer literally has no memory of x ever existing. It's actually deleted from memory. We denote that in our memory diagrams by crossing it out to say that this is no longer in memory. It does not exist anymore. And the program ends. We hit the end of the main method. Oh, and holy crap, we made it through 2 hours and 40 minutes of CSE116, and we are 1/12 of the way through this course already. It's going to go fast. It's going to go fast. So anybody have questions? We got 2 minutes to spare. We saw our first three memory diagrams. It's most of Java. What's coming up is wrapping up the Java stuff. The first part of next lecture will be data structures. We're going to talk about array lists and hash maps. And we will actually, I forgot about that. We will actually introduce the heap on Thursday in 2 days for these data structures. And we'll have references to the heap. Good stuff. And then we'll get into the first CSE116 proper topic, which is unit testing, which will be what you need to do programming task 1. When will the new programming tests be coming out? I want to get to them soon. 4 and 5 are going to need to be reworked from last semester. I think 6, 7, and 8 will be the same as last semester, but if you're familiar with what happened last semester, Task 4 kind of hit the course real hard. It crushed students' souls. So I want to rework that one. So whenever I get to it, hopefully before the next lecture starts. Ideally, I'd like to have all 8 of them released before the next lecture starts. Because you don't have much time to work on them. I want to get them out as soon as I can so you can get started. So the first 3, I figured would give you enough to work on after the first lecture. Alright, and that's my alarm. Alright, lecture over. I'll take a quick break, and then I'll go over to the office hours Zoom meeting. If anybody has questions, I'll be there for my office hours. I'll stay there till 3, even if I'm sitting there by myself. I don't know how many questions there will be yet. I don't know. I actually just don't know. But if y'all have a bunch of questions, I'll be there until 3. I'll be there a little bit before 2, but I'm going to take like 10 minutes or so here and just chill because I've been talking for 2 hours and 40 minutes. Alright. I'm ending the stream. See everybody. Take care. I'll see you Thursday.